This is the second video on area by double integration. In a previous video, we discussed that to find the area over a region R using a double integral, we would let our function f of xy equal 1. This would mean that the height everywhere was 1, and so the double integral would essentially be finding the area of the region R. In this example, we want to sketch the region bounded by the given equations and express the region's area as an iterated double integral and evaluate the integral to find the area. We're given the curves y equals x squared, y equals x minus 2 quantity squared, and y equals 0. Our first step is to graph the region that we're trying to find the area of. So I set up my xy plane, and I know that my first curve, y equals x squared, is a parabola that goes through the points -1, 1, 0, 0, and 1, 1. So I go ahead and graph that parabola, y equals x squared, and now I graph y equals quantity x minus 2 quantity squared. Now the x minus 2 in parentheses is going to shift my parabola to the right by 2. Remember, it always shifts in the opposite direction from the sign that you see. And so this will go through the points 2, 0, 1, 1, and 3, 1. So I can graph that parabola, and then I can see that the area between those two curves and the line y equals 0, or the x-axis, is a small, almost triangular region, but with curved sides, defined by those parabolas. So what I want to do is establish my bounds for my double integral, and the easiest way to do this, the only way to get it into one double integral, is to go from a left bound to a right bound. If I tried to do bottom to top, I would have to split it into two separate calculations, because in one instance the top function would be x squared, and in the other instance the y function would be x minus 2 quantity squared. So instead we'll go left to right. So my left bound is the parabola y equals x squared. And because I'm going left to right, I want to solve this so it's in terms of x equals a function of y. So this is x equals plus or minus square root of y, and we're going to use x equals the positive square root of y since it's the right half of the parabola. Now I want my right bound. My right bound is the parabola y equals x minus 2 quantity squared. I solve this by taking the square root of both sides. So I have plus or minus square root of y equals x minus 2. If I add 2 to both sides, I would get x equals 2 plus or minus the square root of y. Now we're going to use x equals 2 minus the square root of y since it's the left half of the parabola, creating the bound. So we have our x bounds as functions of y, and since x gives function bounds, the y bounds must be constants. Remember, we always have to have constant bounds as our outer integral. So our smallest y is 0, and our largest y is 1. So now we can set up our area double integral as area equals the integral from 0 to 1, those are my y bounds, of the integral square root of y to 2 minus square root of y, those are my x bounds. Of 1, I'm finding an area, so I let my function height equal 1 everywhere, dx, dy. And when I evaluate, I'm going to get the integral from 0 to 1 of 2 minus square root of y, my upper bound, minus square root of y, my lower bound, of dy. Combine the square root of y's, because they're like terms, and I get the integral from 0 to 1 of 2 minus 2y to the 1/2 dy, and then evaluate. This is 2y minus 4/3 y to the 3/2, evaluated from 0 to 1, and I get an area of 2/3. Notice that it always boils down to a single integral where you have constant bounds, and you're basically getting your right function minus your left function. Or if you were doing a bottom to top, you'd get your top function minus your bottom function. So it boils down to the same thing you did in Calculus 2 with integration to find area, but we're setting it up with our functions as bounds to start with. So remember, key points are when you're finding an area, your function value, which is your integrand, should be 1, and then you always have to have your constant bounds as your outer integral, and that will find you the area of the region.